All
right, section 6, complex numbers. So, talked about that just a little bit. Complex numbers deal with imaginary numbers. So if I show you a thing or two here. A complex number, write this down. Under complex numbers, write A plus BI. This is a complex number in what we call standard form. Now, A is something and B is something. Anybody know what A is? You guys ever deal with a complex number before? I get to teach you something the hog ones haven't taught you yet. Okay, letter A is the real number. Notice over here, the BI. I is what? What do you think I stands for?
Imaginary.
Imaginary. See, this is the imaginary unit over here. Okay? So BI is your imaginary number, and A is your real number. Why is it complex? Because we mixed a real number with an imaginary number. That's why we call it complex. Okay? So, see, a complex number consists of a real number and an imaginary number at the same time. Now, what is the imaginary number? Can you use imaginary numbers? Or is it like imaginary friends? Is it not there? Sam, you can tell me about this. I'm sorry, that wasn't right.
Nice.
I remember doing that. I remember doing that to John Bay. You guys know John Bay?
Yeah.
I remember saying that to him four years ago. 4 years ago. He wasn't too happy with me. I apologize, Sam. Don't be mad at me. Okay? No. Then I had to start making jokes about myself, and it wasn't as funny to me. But imaginary numbers. Can we use them? Can we use imaginary friends? No. Can we use imaginary numbers? Yes. Actually, we do. Anybody know where we use imaginary numbers? Yeah?
Like sometimes there are like imaginary solutions to a quadratic equation.
Yeah?
It's not like plotted, like you can kind of know.
Yep. Yep. True. We use it there. Anywhere else? Any real jobs in real life?
Really, not real life.
Well, what were you thinking?
I
Go.
was thinking about like negative root.
Negative root? Yeah, we're going to use imaginary numbers. And if we squared a negative number, imaginary numbers, yes. And a real job. Anybody think of a real job that uses imaginary numbers? Sam? Maybe. Not that I know of. Maybe. You guys know engineers? Like anybody want to be an engineer? Okay. You're going to use imaginary numbers. Okay. No, electrical engineer, I guess, would use it. They use it to measure like volts, wattage, all that kind of stuff, like electricity. Okay. They use imaginary numbers to measure electricity. Okay. Quantum physics. I don't know much about quantum physics, but all I know is they use imaginary numbers for things. Okay. Yeah, probably, yeah. So they actually do have uses for imaginary numbers. You wouldn't think so because they call them imaginary, but they do have uses. So look at example 1 here. Solve this equation. Now, how are you going to solve this one right here? We're going to get x by itself. We're not going to factor. Here's a problem that people had on the test. They weren't sure. Should I factor this or should I not? Okay? So they looked at something like this and they wrote down on my test, cannot factor. Yes, I know this. You can't factor this. Okay? Why is it? What are we looking for when we do factor normally? Okay? Yeah. This, you're saying? What are we saying? Okay, true. Yeah, that's not what I'm thinking of, but yeah, true. Sam?
For this, for factoring,
Yeah.
if you can't factor, then this cannot be factored.
Yeah. In this case, this can't be factored. So somebody might write that, but that wasn't the whole goal. Colleen, what were you thinking? Okay, yeah, that's what I was thinking. Like, why don't I factor this right here? There's no bx, right? So I'm not going to say let's factor. All right? So yeah, good idea.
Yeah.
What?
No,
Oh.
different situation.
Yeah, different situation, right? Different situation, you're going to apply different things. So this one I would not even look to factor. I would just say let's get x by itself. So minus 11, minus 11. Do this with me. 2x squared equals negative 48. Next step, divide by 2. Divide by 2, divide by 2. X squared equals negative 24. Same step as before. How do you get rid of a square? You do the opposite. Square root, which means you have to square root this side. This becomes square root of x squared. X equals what? Plus or minus. People forgot that. I emphasized that. I said, don't forget. Still, I knew it happened. Okay? Plus or minus, right? As soon as you square root x squared, you know right here, I know there's two answers. Plus or minus. Plus or minus. Now, how do you break this down? That's the new part of today. How do you break down the square root of negative 24? Let me write this down. How could you solve this? X squared equals negative 9. What value of x could you put in here to give you negative 9 out here? Negative 3? Put in negative 3. What do you get? 9. No. Positive 3? No.
Cannot be.
Yep. Here's where we use the imaginary number. You can't, any real number, if you square it, will always be positive. There's no real number, if you square it, will be negative 9. That's where imaginary numbers comes into play. Okay, so right here. Actually, let's finish this one. This one might be a little easier. Let's do the same thing. Square root, square root. Square root of x squared, x. Square root negative 9. Okay, definitely a plus or minus. Now, here's how you want to break this up. Anytime you get a negative underneath the root, you want to do this. Square root of negative 1 times the square root of 9. You see what I did? Square root of negative 9 is square root of negative 1 times square root of 9. Square root of 9 is 3. Now, question is, what's the square root of negative 1? This is our I. I is equal to the square root of negative 1. Star this. Know this.
Is that like the standard?
No, this is just what I is. The imaginary number, the imaginary unit is equal to square root of negative 1.
Just for this.
Actually, for all.
For all.
For all. The imaginary unit is equal to square root of negative 1. Keep this in a star. Note this. Now we're going to tell you something else in a moment. So, here's what I got. Square root of 9 is 3. Square root of negative 1, I. Some people might put I3. We're not playing bingo, okay? Alright? Not playing bingo. So, you want to keep, it's just like X. You wouldn't say X3, right? You'd say 3X. Same thing here. 3I. Alright, here's my answer. Plus or minus 3I. So if I put 3I in here and I squared it, yes, I would get negative 9. If I put negative 3I here and I squared it, I would get negative 9. You'll see how that works in a little bit. Let's do this one though. What is the square root of negative 24? First thing I always do, get rid of that negative. Square root of negative 1. I always pull that out so that later I'm just like, okay, square root of negative 1 is this. Okay, now, square root of 24. How about that? Square root of 4, square root 6. Notice if I multiplied all these, I would get this, right? Okay, so I broke it down correctly. Let's simplify. Square root of negative 1, square root of 4, which is?
2.
2. Square root of negative 1? I. Square root of 6?
Square root of 6.
Just square root of 6. Yes, okay, another thing here. Put the numbers like 2 out front, put I out front too. Don't put I afterward, because then it looks like some people put I underneath the radical. No, no, no. Okay? Keep the radical last. Keep the I, the 2's, all the numbers out front. Okay? Remember that. Final answer, right there.
Oh, that's the final.
That's it. Plus or minus 2I root 6. If you put this answer in here for X, you would get negative 37.
How do you do that on the calculator?
You don't. Unless you had a TI 89, probably would work. I don't know. Never tried it. TI 84?
Can we get a TI?
No. Okay? Know this stuff by hand here. Okay, everybody understand how I got this answer? Okay? You got to use imaginary, you got to use complex numbers to solve. Okay? So let me get you one here. So let's go to a 3-step. There's a 3-stepper right there. Number 5. And Sally Lee, what do you got? Same answer. Huh. Perfect. Here we go. Last one, same thing. These are all the same idea, so don't worry about the last one. We'll do another one. All the same idea. So if you're getting those answers, you're pretty good so far. All right, Okay, so example 1 was solving equations with complex numbers. Can you do it so far? Hopefully yes, but you got to practice what you learned. Example 2 is all about adding and subtracting complex excuse me, numbers. So if you pretend I is like X, then the only thing people mess up on is, did you distribute this minus to 6 and the minus to 7i? If you didn't do that, which probably a quarter of the people didn't, you got the wrong answer. Alright, so we got 10 minus 6 and then minus this, so minus 7i plus 4i. Put it together, 10 minus 6, 4, negative 7i plus 4i minus 3i. Final answer. Okay? Good job. You can add and subtract. Way to go. Here we go. Ready? Let's get the harder stuff. But actually, you have to make sure your answer is in a certain way. Watch what I mean by that. See this question right here? Actually, my slides are messed up. I should have fixed this, but I haven't. Keep forgetting. Here's the question. Write the expression as a complex number in standard form. What did I tell you what standard form was? A plus bi. If it's not in that order, guess what? It's not standard form. Which if you switch the order, I'll take a point off. Those points add up if you don't pay attention to details. Okay? So make sure. We just did C. You did it all. You got what? 4 minus 3i? It is in A plus bi form, so that's why we could circle it, say it's good. Okay? Look at these two. A and B. This is just adding and subtracting here, folks. It's, nothing crazy. This is easy points on the quiz or test, right? 7 minus 3, 4, negative 6 minus negative 6i. What is that?
Negative 12.
Zero.
What?
That's a common mistake, Sam. You did it.
What happened?
You did the common mistake. You got to think about it.
Oh.
Negative 6 minus
You-
negative 6. Common mistake.
Stop.
Common. Okay? Which is 0. So 4, you don't write plus 0 I, it's just 0. So just 4. That is standard form with just the I measuring unit is not there. And the first one up here, 8 plus 5, 13. Negative I plus 4i is 3i. A plus bi form, yes, circle it. I'm telling you, I'm going to get people right here. I'm already telling you ahead of time. Okay? A plus bi. Okay? Put it in that form, or it won't be fully correct. Why is that? I don't know why. Those mathematicians can make up their own rules, I guess. Any questions on this? No, right? Just add and subtract it. So let's go to the next example, which is multiplying. Write that expression as a complex number in standard form. So, what are you going to do with letter A? What property? Distribute. Go ahead. Distribute. I'll wake up. You guys stand up. Distribute, and then just look at your answer for a moment. And if I went around, I'd probably say most papers have the wrong answer. Because you don't know something yet. Well, maybe you do. Is your answer A plus BI?
No.
Some of you might know it, some of you might have changed it, but it's not, right? So you got to make it A plus BI. So there's one more fact you have to know. Let's distribute here to here, here to here. What is this? Negative 24i. What? Plus 4i squared. I times I squared. Now this is not a plus bi, even if I switched it around. So you have to know something. I squared equals something. You knew this. Good. You knew I is equal to square root of negative 1. So think about this. What is I squared? Well, square I. I'm doing that here. If I square this side, I'm going to square this side. I squared becomes, what is it? Square and a square root cancel. Negative 1. Star this idea. I squared is negative 1. You have to know that. So now we can go back to our problem. Instead of I squared, so in any case, you put this on my test. If you ever see an I squared, you change it. Negative 1 you put in there. So we really got negative 24I plus 4 times negative 1, right? I squared is negative 1. Now make this look nice. Negative 24I minus 4, right? Circle?
No.
Standard form says A plus BI. So people do all this work and then forget that little fact at the end. Negative 4 minus 24I. Now it's A plus BI. There we go. You got it? Okay. Knowing that fact right there, I squared is negative 1, I want you to do letter B by yourself. Go. Alright, let's look. Do some FOIL. 9 times negative 4, negative 36. 9 times 7i plus 63i. Negative 2i, negative 4, positive 8i, negative 2i, positive 7, negative 14, and here's where people make the mistake. They just put I. I squared. So, here's what I do. Simplify 63 and 8, 71 i's. Negative 36, and then since I squared is negative 1, you put it there. So this becomes negative 14 out front, and then negative 1 beside it, which makes it plus 14. So we got negative 36, and then we got positive 14 right here, which makes negative 22 plus A plus BI. There you go. How many got that one? Okay. Okay, good. Whole class. Oh man, I should just quit teaching then. Alright, example 4. Multiplying complex numbers. The key is look for I squareds, simplify, make it A plus BI. That's the key to example type number 4.